In this video, we would like to show the process behind designing a wing. It consists of 4 stages: conceptual design, preliminary design, detailed design, and acceptance. The first stage of the design process is the conceptual design. The purpose of this stage is to develop an understanding of the product that we want to produce and to create a clear starting point. Based on the given structural requirements, we produced a sketch of the wing. While drawing the initial sketch, it is also important to take into consideration the loading specification, that is, the forces and moments that the wing will have to withstand. The second stage is the preliminary design stage. Having made initial decisions about the configuration of the wing, it is important to decide on the geometry. This stage allows us to make predictions about the performance of the wing and optimize its dimensions to satisfy all requirements. In order to better understand how the geometry affects the behaviour of the wing, we went through beam theory, and later used Microsoft Excel to obtain numerical data. Using Excel also allowed us to list out every possible configuration for the spar, which made it easier to decide on the final dimensions. The second moment of area, one of the variables in the equation for stress, is directly proportional to the height cubed and linearly related to width. In practice, it means that altering the height gives greater changes in stress and therefore allows us to better utilise the material and make the spar lighter. The next stage of the design process is the detailed design stage. The main point of this stage is to visualise a product and investigate the best possible solution among those developed in the previous stages. It also allows us to evaluate if the product can be manufactured and how different parts will be joined together. We used SolidWorks to develop our product in CAD, which included a spar, ribs, a leading edge, a trailing edge, and glue. One of the main objectives of designing a wing is to minimise the mass of the structure. By introducing a spar with a varying cross-sectional area, we were able to reduce the mass by 20%, without compromising the load carrying capabilities. After optimizing the design in Excel and assembling the product in SolidWorks, we needed to run tests and simulations to see if the design would behave in the predicted manner. We decided to use SolidWorks again for this stage of development because it can simulate real conditions and measure quantities without using professional measuring equipment. After running a few tests on the spar with the initial geometry, it turned out that the design didn't meet the necessary requirements. That's why this stage is particularly important, as it determines if a prototype meets the demands needed to be sent out for production. It is also vital because when the prototype doesn't satisfy the criteria, we can make conclusions about why the part failed and implement what we have learned into the next design cycle. After repeating our cycle, we managed to produce a design that met all the requirements.